Welcome to 5G Hub. In this video, we will talk about control and data planes in traditional network. Before discussing what is software-defined network and what are the power of this technology, let's take a look for the traditional network devices. Every single network device has to perform at least three distinct activities. First one is process the transit traffic. That's why we buy them in the data plane. Second is figure out what is going on around it with the control plane protocols. Finally, interact with its owner or network management system through the management plane. Now stop and think about what networking devices do. What does a router do? What does a switch do? Many ideas should come to mind. For instance, routers and switches physically connected to each other with cables and with wireless to create networks. The forward messages switches forward Ethernet frames and routers forward packets. They use many different protocols to learn useful information, such as routing protocols for learning network layer routes. So here in traditional network, each device has its own data and control planes. So what is a data plane and what is a control plane? The term data plane refers to the tasks that a networking device does to forward a message. In other words, anything to do with receiving data, processing it, and forwarding that same data, whether you call the data a frame, a packet, or more about message, is part of a data plane. For example, think about how routers forward IP packets as shown in this figure. If you focus on layer 3 logic for a moment, the host sends the packet step 1 to its default router number 1. Router number 1 does some processing on the received packet, makes a forwarding routing decision, and forwards the packet to step number 2. Router number 3 and router number 4, for example, also receive, process, and forward the packet step number 3 and 4. So by the way, the data plane is often called the forwarding plane. Next, take a moment to think the kinds of information that the data plane needs to know beforehand so that it can work well. For instance, routers need IP routes in routing table before the data plane can forward packets. For example, layer 2 switches need entries in a MAC address table before they can forward frames out the one base port to reach the destination. So the term control plane refers to any action that controls the data plane. Most of these actions have to do with creating the tables used by data plane as we discussed in the previous slide. Tables like IP routing table and IP address resolution table, also a switch MAC address table, and so on. By adding to, removing, and changing entries to the tables used by the data plane, the control plane process control what the data plane does. So in traditional network, use both a distributed data plane and distributed control plane. In other words, each device has a data plane and a control plane, and the network distributes this function into each individual device. As you see in this figure, router 1 will have control plane, router 2 have data plane and control plane, router 3 have a control plane and data plane, and also there is another way or another plane for the data plane included on each router of them. In next video, we will see how and why software-defined network or SDN decouple the control and data plane. Thank you for watching and see you in next video.